Hello, my dear students. Today I will tell you a trick. Most of the students do this kind of integral the long way, but that trick can make you solve it in minutes, in just 2 or 3 minutes. I'll tell you the trick. This is the main problem, and here this is a differential dx, and it is necessary to write it after the fraction or after the integral. Without it, the examiner can cut your marks. Okay, what's the core observation here? Look at the denominator, this one, x squared plus 1. What is its derivative? The derivative is 2x. You can differentiate the denominator in your mind. There's no need to write it on the board. So 2x is already in the numerator. So it means that this integral is not really difficult. It's actually a hidden logarithm. Hidden logarithm. Understand? Now I will explain it to you. Stay with us. Look, it's 2x over x squared plus 1 dx. Okay, before applying any method, always compare that the numerator is the denominator, is the derivative of the denominator. So then you can write here, I tell you, just a minute. Here, look. Now, d over dx x squared plus 1 is equal to 2x. So numerator is exactly the derivative of the denominator. So it means that substitution will collapse the integral. Don't substitute here. Okay? So don't substitute mindlessly. Look, substitute with a clever eye. Here, let u is equal to x squared plus 1. And then take the derivative. du is equal to 2x dx. And the integral becomes, if I substitute here, it's u, and this one is, you can see, this whole is u, and this thing here on the top, this is du, as you can see clearly. Now I write it here. Look, 2x dx is equal to du, and x squared plus 1 is u. Isn't it clear now? Now you can integrate it with just one simple principle, and that is natural log of u. So it is equal to natural log ln of, and take care of these sign, these absolute value, natural log of the absolute value of u, because if you use parentheses here, square brackets, that will be wrong, because natural log does not accept any negative value. It always accepts only positive value. So here you must write ln absolute value of u. And now, one of the most frequent errors usually students commit, I tell you, they don't write a constant of integration. I'll not tell you why we write it, but it's essential. Write it, otherwise the examiner can deduct your marks. So here, now you can substitute back the value. Don't forget that u is not our original variable. Now substitute back the value in terms of x. So I will write here, this thing will take the form x squared plus 1 and absolute value of x squared plus 1 plus c. Isn't it simple? Now I give you another example. Here I write another for integral. So that is 3x squared divided by x cubed plus 5. Now, my dear students, you have actually captured the idea. Now idea is in your grasp. Now directly look at the denominator. It's x3 plus 5 and differentiate it in your mind quickly. Within seconds, you will find that its derivative is right on the top without even any change of a number. You don't have to multiply or divide anything with the numerator. It's originally on the top. Here, I'll look d over dx. No need to write it. Just for your understanding, I'm writing it that its derivative is 3x squared, which is right on the top. So why don't you wait? Why? Here, now you can substitute very cleverly, and a clever substitution will save many precious minutes of exams. Here, u is equal to x cubed plus 5 and du is equal to 3x squared dx. That is on the top, as you can see. Look here, 3x squared dx and x cubed plus 5. Okay, so I write it here. Look, 3x squared dx. I replace it with du, and here x cubed plus 5 is u. I write it here. And now I'm ready to integrate. Again, the integration is so easy. In just one step, I can find its integration. It's ln, absolute value of u, plus constant of integration. And now don't forget to substitute the original expression here. ln x cubed plus 5 plus c. Do you want more examples? Okay, one more. I give you one more example. Stay with us. And here is cos x. It's trigonometric function over sine x dx. Okay, so sine x is denominator and derivative is cos x. So substitute u is equal to sine x and du is equal to cos x dx. Perfect. Here you can see it's in the denominator du. So right here du over numerator. Okay, it's a numerator divided by denominator is u, and now integrated ln u plus c, and ln now substitute back, it's sine x plus c. Yes, this principle can lead you to solve many difficult integrals that are apparently difficult to evaluate. You can integrate them, saving much time in the exams, many minutes. You can save it. You can solve it in just a few steps. And yes, there are difficult cases. We can handle them. If we keep in mind this key idea, we can apply it to many tricky questions too. Thank you, my dear students, for watching this video till the end. Bye.